This is Matt Slauson. I'm in my shop at home and trying to stay away from everybody. I teach principles of engineering as well as other project lead the way classes. And I'm in front of my metal lathe to show people how to create a tensile test sample. So I'm going to focus in on the lathe and talk about what it is we're going to create in just a second. So this is a piece of brass that I cut to approximately 3 inches in length. And what I'm going to do is turn about an inch of the middle section down to 0.100 inches in diameter. And then I'm going to thread each end of the tensile test sample. So what tensile test samples are used for is to figure out the properties of the material that you are working with. So this is 360 brass, I believe, and so you could get a machinist manual and look up what the tensile strength is of this particular type of brass. You could find out the modulus of elasticity and the stress and strain attributes of this material by looking it up. So what you do with a tensile test sample is you turn it to a known diameter, and then you apply a force on it, and you pull it apart or put tensile stress on it until it breaks. So by taking very accurate measurements of the dimensions of the area that's turned down to 0.100 or 1/10 of an inch, you can figure out the modulus of elasticity and the properties of this material, or any material for that matter. So here we go. So the first thing I did again was I cut it to length, so it's approximately 3 inches. I'm going to chuck it up and face the ends off. So for those of you that don't have a lathe at your school, we actually have 3 different metal lathes. The first thing I'm going to do, and I have it chucked up so I just have a small amount of the brass sticking out. I'm going to face it off so that I get a nice even cut across it. And I have tooling up on the wall over here. And this is a quick change tool post. And it's going to get loud, so warning. So I'm going to face and chamfer each end to start with, and then on one of the ends, and I only need to do this on one of the ends, I'm going to center drill it so that it comes out, so I can support it on the end as I turn. So there's the, well, I got to bump the camera a little bit here because it's my tailstock's in the way. Hopefully that's still okay. All right. Okay, so I have it faced. And now what I'm going to do is center drill. I'm going to take this tool out, and I'm going to put this tool in. So this is going to create a hole in the end of the tensile test sample that will be used to support the end so I can turn the middle of the sample. Hopefully you can see this. So my students at school actually make their own tensile test sample, so it's going to get loud again. so hopefully you can see that the end of this now has a hole in it, and what I'm going to do is I'm going to use this ball bearing center as a support to hold that up as I'm turning the center. So get that set up. And so what I'm going to do is I'm going to chuck about a half of an inch into the chuck, and I'm going to bring the support out this way. And try to make sure everything's good and tight here. Tight. And now I'm going to use a tool that will cut from right to left. And you see what I got here? This one looks pretty good. So this tool is high-speed steel, so it's a lot harder than the brass. And the way it's ground, it's going to enable me to cut from the right to the left. And again, the measurements aren't critical. We're trying to hit about 1 inch of material turned down to 0.100. It doesn't matter as long as you measure. So when we get done turning it down, I need to take accurate measurements. The reason why we're trying to hit 0.100 is because our tensile tester at school can only apply 1,000 pounds worth of force onto the tensile, and 0.1, if you turn the brass down to 0.1, it will fall within that range. So that's the reason for doing that. So I'm going to get a dial caliper. All right, so I've got a dial caliper so I can measure that. And so here we go. And I have 2 marks on here at about 1 inch. And I'm using the power feed on my leg so I don't have to turn the lever to turn the wheel. And the brass started out as 1/4 of an inch, and I'm going to say I'm down to about 3/16 of an inch right now. So when I get close, I'm going to start measuring. I've done this enough. The next step I'm going to do is to thread the ends of this. So our Tensile tester has a fixture on it that has 1/4 inch nominal diameter, 20 threads per inch for holding the tensile tester. So I got to thread the ends of this to 1/4 20. So what I'm going to do is I'm going to chuck up the tensile test sample so that I have about 1/2 of an inch sticking out. And now I'm going to go grab my my die stock and die. So to thread this, I'm going to use a die stock with a die on it, and the die has a tapered end at the beginning, and that's so it makes it easier to start. And what you want to make sure you do is keep the die stock perpendicular to the center line of the lay. So I'm going to use the tail stock up against it, So I'm going to hold my die stock there, and I'm just going to keep slight pressure with the tailstock against my piece of brass, and I'm just going to turn it, and that should keep things fairly perpendicular. And so once I get it started, I can finish threading it, get everything out of the way. And there's the threads from my tensile test sample. So the next step is going to be doing some measuring to figure out all the sizes and getting it ready to put in the tensile tester.